All right. All right, back to this. So let's make an X and Y list. So what do we know in the X direction?
We know
The time.
Yeah.
Okay, we know time is what?
1.7.
1.7 seconds, right?
No.
Is that only in the X direction? No, it's also in the
Why?
Y because time is a
Scalar.
okay. So time in both directions is 1.7 seconds, right? What else do we know?
The D naught for the X direction is 0.
Okay.
And the final was 10.
Okay.
Whoa.
What else do we know?
D naught on the Y is 0.
Okay.
Why are you going too fast?
Is just D naught in the Y 0?
No, the final is 0.
D final is 0 because it ends on the ground, right?
Yeah. But no, unless it went so fast that it's something.
Could have happened.
Why not?
Catapult's not that strong.
Are you sure?
Yeah, landed on asphalt.
But gravity. Oh.
Okay.
I thought you meant
Oh, gravity. Where does gravity come into this?
Oh, negative that point.
X or Y?
Wow.
it's not like I could say that.
So it's negative means we're probably calling to the right and not positive. What else do we know? X direction. What's our acceleration?
0.
0. Yep. As long as we're not counting air resistance. Do we know initial velocity in the X direction?
No.
Do we know initial velocity in the Y direction?
No.
We know final velocity in the Y direction?
No.
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 We know final velocity in the X
Stop
direction
asking all these
equals
questions
no.
you don't answer.
Part of teaching it is asking questions I know the answers to. Like this problem. Alright. So we have our lists. We have the situation. We need to figure out the launch velocity, right? Now, because we're given time, right, this problem we probably only need to look at in one direction. We can look at it in both directions, or we can pick a direction. Because the interesting thing is that this 55-degree angle
I don't think that's interesting.
makes up a triangle, right? Where this is the x component and this is the y component. And we know that the x component equals v sine 55, or sorry, v cosine 55, right? It's adjacent. The y component is v sine 55, right? So it's opposite. So if we can find the x or the y component, doesn't matter which one, we can use the trigonometry equations to figure out v. Remember, here's our trigonometry equations. So if we can find x or y, it doesn't matter. All right. Then we can figure out the launch velocity. So which one do you guys want to find, x or y? Y? Okay, we can find y. So I want to find v initial in the y direction, right? So given what I have, time, displacement, or position, and acceleration, what equation should we use?
3.
Equation 3? So equation 3 says, this is in the y direction, d equals d, or,
You should do that. You should write the equation.
good. 1/2 at squared plus v naught t plus d naught, right?
Yeah.
So 0 equals 1/2 times negative 9.8 times 1.7 squared plus v naught times 1.7 plus 0.
That's what I hate. You can't just say a number for something.
So can we figure out what v naught is? Theoretically, I think you actually can. Using algebra, right? So let's do this. Negative 9.8 times 1.7 squared times 1/2. What does this equal? This first part.
I'm concerned about it.
Okay. 1/2 times negative 9.8 times 1.7 squared. What is that?
Negative 14.1 or 2.
Negative 14.2
Yeah.
plus 1.7 v naught, right? And what do we do now?
How do we just subtract stuff?
Okay, subtract what?
1.7?
1.7? Okay. So it's not just 1.7, it's 1.7 V naught. Right? Yeah, we're right over here, so. Then we'll keep going here.
Then we should divide by negative.
So negative 1.7 V naught equals negative 14.2.
And we should divide.
Divide by.
Negative 1.7.
And we end up with V naught equaling
Equals 8.4.
8.4 what? Is it 8.4?
Well, it's 8.352941176.
Yeah. Alright, we'll go 8.4. Oh, meters per second.
What was it?
So now we've found the y component. We know this right here is 8.4 meters per second. The back number goes to me. Okay. So you know that is 8.4 meters per second. Does that make sense? Yeah. So we could use the Vx and the Vy equation. Doesn't matter. Well, it does now. What do we find here? 8.4. Is that Vx or Vy? Vy. So we could use Vy to find V, right?
Mm-hmm.
So we know that, so using the Vy equation, we know that 8.4 equals V sine 55, right? Radians or degrees? No. Degrees. Sine 55 in degrees is what? Sine 55 in degrees is 0.8. 0.82.
Yeah.
Divide by 0.82. Or 819, if you want, Michael. 8.4 divided by 0.819, or 0.82.
10.243.
So that is our launch velocity. Does that make sense?
Yeah.
Now, did we only have to use the y direction? No. We could use our information from the x direction as well. Okay. Now you don't have to do this, but if what equation would I use the x direction? Would I use if I did the x direction? 1, 2, 3, 4, 5, or 6?
5.
5, right? If I'm using only the x direction, so I'm going to do this up here. Okay. And once again, you do not have to do both. I'm just proving a point to you. Okay. D is 10 equals V times 1.7 plus 0. 10 divided by 1.7 and we get, what's 10 divided by 1.7? Calculators. 5.8? Okay, so 5.9?
Yeah.
So that's our velocity in the x. So now instead of using Vy equals V sine theta, we could use Vx equals V cosine theta. Should I get the same answer?
Yes.
Let's check. So we know 5.9 equals V cosine 55. Right? So 5.9 divided by the cosine of 55, whatever that number was. You said it was what, Omer? 10.3? Okay. So they're approximately the same. Close enough. Why would they be a little off?
Because this one we rounded and that one we just divided by.
Okay. Also down here, when we're using equation 3, did we round?
Yeah.
Yeah. So in the rounding we did here, that caused our answers to be a little bit different, but that's okay. Right. What's another way I know these two components, right?
I don't know which one.
What's another way I could do?
By using.
We could also use Pythagorean theorem and find that component.
Yeah.
Okay. Does that make sense?
Yeah.
Now the last part of this problem says, will this make it? It's not that long, huh?
It doesn't say that.
Will this make it over a 3.5 meter tall house?
No, you're gonna hit it.
Now, a smart Mr. Branch will put the 3.5 meter tall house where in the trajectory?
Perfect path.
Right in the middle. Why right in the middle?
That's the highest point.
Good, that's its highest point. So this spot, 3.5 meters. There's the house, kind of skinny house. Okay, 3.5 meters. What do we know about the time at this point?
1.7.
It's half of
Half.
1.7.
Half. So time at the highest point is half the total, right?
Yeah.
So it equals half of 1.7, which is 0.85, right? So if I want to figure out if the rock will make it over the house, right? No. Which direction should I look in, the X or the Y?
Why?
We should look at the Y direction, right? Now for this part of the problem though, what are we changing in my list? Is time still 1.7? No, time is now what? 25. Stop saying baby. The rock.
Baby.
D naught, we still start on the ground, right?
Yeah.
Are we ending on the ground?
No,
No, what height are we ending at?
we don't know.
We don't know, good. It's not 3.5. Because we want to know if we'll get over the 3.5. Okay. What else do we know? Do we know any of these down here?
Actually, we do.
We do. Which one do we know?
It's 8.4.
We don't know both.
Isn't it V9?
Nope.
Not?
We know V naught. What's V naught, Kyle?
8.4.
8.4, because that's the Y component, right?
Oh, I see.
So now, can we find that final height,
Yeah.
given our new Y list?
I think we use number 3.
We do use number 3. Usually in the Y direction, we use number 3. You guys notice that trend? Seems like every time in the Y direction, we're using equation 3.
Yeah.
So, the second part about the height. We are going to use equation 3. Rex, watch your mouth.
What? That's the title.
Okay,
The title of the movie.
doesn't matter. It's still kind of weird. Okay, so D equals 1/2 AT squared plus V naught T plus D naught, right? No, because that's short for Richard.
No, what if
Like
I
your
birth
Okay.
certificate
Gentlemen. So, D final we do not know. Assuming you're referring to someone named Richard.
Oh, yeah.
Okay. So, 1/2 times negative 9.8. I have no idea as well.
It's like-
Okay, gentlemen, let's work on physics right now. We'll worry about the more important things later. Okay? So, oh gosh. I think some people need to stay after class with me. Alright, so 1/2 times negative 9.8 times 0.85 squared plus, what's V naught? 8.4 times the time, which is 0.85 plus 0. So that's our equation. Now we need to solve that for D. So this one will be kind of easy. Right? No algebra. Just plug in your calculator.
Well, it's 3.59 plus 3.6.
So the maximum height the rock reaches. You got it. It's fine. Stay student speaking. So the maximum height the rock reaches is 3.59 meters.
Hello.
Does that make sense?
Yeah.
Are there any questions?
No.
Nope. All right. Nice job.